By the way, which of you attended the WAP talk by Thomas before lunch? Raise your hand. Very interesting talk. See, we have Thomas here. Very, very insightful. By the way, if you like iceberg branches, you're going to love this. Raise your hand if you ever introduced changes at work to your data, which eventually broke your production environment. Don't be shy, guys. We've all been there. Okay, it happens. How many of you, by the way, are still working in the same company? Great. So, hi, my name is Nir, and I'm a core committer at LakeFS and the developer of the high-level Python SDK. So LakeFS is an open source project maintained by a community and managed by Traverse. Today we're going to talk about data version control. So for me, working in the software industry, no matter which company I was working for, the coding language we were using, or the location of the tech stack, there was always one thing that was constant in my work. We were always using source control to manage our projects, right? So our mission in LakeFS is to become to data practitioners what Git is to software developers. And through that, implement engineering best practices in data. I'd like to start this talk by looking at the project's lifecycle with respect to the code and the data. So during the development stage, what happens if we need to make code changes? So what we'll do is we'll branch out from our main branch, right? We'll perform all our code changes in isolation. We'll add some tests to it, and we're going to test it. And when we're satisfied, we're going to merge it back to our main branch. But what happens when we want to introduce data? So testing big data can be a challenge due to the volume, velocity, and variety of data sources. This makes creating tests that are maintainable and predictable a challenge. On top of that, the distributed nature of data processing introduces concurrency, scalability, and performance complexities. All of that makes creating automated testing processes hard. So what would we usually do in our situation? Well, we'd usually take a sample of our data, and we'll test it against our pipeline or some test pipelines that we created for it. And if the tests pass, we'll feel confident enough that our data is valid. Moving on to the deployment stage. So every code project that respects itself has a continuous integration and deployment process in place. In that process, we're going to run integration tests and user acceptance tests. And once these tests pass, they're going to be the code is going to be automatically promoted to production. But what do we do with the data? Well, there's not a lot that we can do, right? We're not going to test the whole data set during deployment, right? It's going to take a lot of time, and we don't have that time. So what we'll usually do is we're going to rely on the tests that we made on our sample data during the development stage, right? But what we're actually doing is that we are testing our data in production. But what happens when something goes wrong? Well, if we have a bug in our code, we can always roll back to the latest viable version, right? But what happens if we have faulty data? Or we accidentally deleted data that's important? Well, corrupted data in production can lead to very unfortunate outcomes. This is a good example of it. So what happened here is, well, maybe some of you heard about this story. Maybe some of you were even affected by it. What happened was that the FAA's noting system, it's a system that there for pilots to alert about potential hazards during their flight. Well, it broke down. Well, it broke down due to damage to the database. Now we all know what that means, right? That resulted in over 32,000 flights delayed, which is millions of really pissed off passengers and millions of dollars lost. Now I wonder if the person who accidentally damaged the database still works there. I'm guessing they're not. But we ask ourselves, how can we avoid these situations? Well, the good thing is, all of these problems were already solved for code, right? So why not manage your data like you manage your code? So what is LakeFS? Most of you use an object store to store all your data. That can be different kind of storage providers. It could be on-prem, whatever. But what if you could use that object store and just check out a branch from it and perform all your experiments? Test the changes, and if everything passes, merge it back to your main branch. Well, this is what LakeFS does. It provides Git-like operations at a scale of petabytes over your data lake. So how does LakeFS work? So LakeFS sits on top of your object store. That, as I said, it could be AWS S3, Azure Blob Storage, GCS, and it exposes Git-like operations of your, via our OpenAPI interface. We provide GUI as well as CLI, Java, and Python clients. And we integrate with common tools for processing, analysis, and orchestration of our data. But for this to work at scale, there are some requirements that need to be met. The first one is, this should be inexpensive. And that means that we can't copy our entire data lake every time we want to create a branch, right? Secondly, it should be format agnostic. We shouldn't care about which data is going into our data lake. It should be fast, which means that operations that we are performing should be just as fast or close as possible to working directly with your object store. And lastly, it should be efficient. And that means that operations like diffing and merging should optimally not require dealing with the data directly. So how does LakeFS work under the hood? And this is a very high-level explanation of how it works, because this can take the whole day. So basically, LakeFS commits are represented by an immutable set of pointers to the data. Your data continues to sit on the object store, but the data versioning is managed by LakeFS. So making a change on the branch, for example, modifying an object, means that our branch now needs to point to the new location of the updated object. Versioning operations are therefore painless, because there are operations on pointers of the data and not the data itself. And of course, since we're saving the entire commit history for our branch, we can always travel back in time to any commit we want. So let's discuss LakeFS's capabilities for each of the lifecycle stages. So during development, we can experiment in isolation. We can check out a branch, we can perform all the code changes we want, test it against new data and new tools. All the while, our production branch remains untouched. We can also use it to debug. If we have a faulty branch, we can make a snapshot out of it and use that snapshot, that branch, to investigate the issues. And lastly, we can collaborate on our branches, just like software developers collaborate with Git. During the deployment, we have a clear version history allowing data consumers to understand exactly what new data was introduced. And we can add data quality checks using LakeFS's actions and hooks. For example, I can create a post-merge hook on my production branch that will perform data quality checks on the new data ensuring the data is valid before it's introduced into our production branch. What happens when something goes wrong in production? So when our production breaks, there are two very important things that we want to do. The first thing we want to do is we want to roll back to a working version as fast as possible. Now this can happen almost instantaneously, right? Because this is now an operation on pointers and not on the data. But one more important thing that people tend to neglect is we want to understand what is the root cause of the issue. So we can actually take a snapshot of our broken production branch and use that to root cause a problem and investigate while we're rolling back our production environment and making sure that it's running perfectly. So this is how LakeFS helps us during the development lifecycle. But LakeFS also provides us with another very useful use case. Sometimes, or many times, we'd like to make changes, a series of changes to our data, but we'd like the changes to take effect only after we've performed all of them successfully. In the traditional world of databases, we already have a solution for that. That's called a transaction. A transaction is a unit of work that consists of one or more operations that can be performed on one or more tables and is treated as a single indivisible unit. The atomic property of transaction ensures us that either all the operations under that transaction occur or none do. So the question is, how would that look like in the world of data lakes? Well, data lakes contain a lot of different types of data. They contain structured data like delta and iceberg tables, but they can also contain unstructured data like media files, text files, sensor data, etc. In this case, it's not enough to have transactions just on the table level, right? So how do we create transactions over the entire data lake using LakeFS? Well, we can try and leverage LakeFS's versioning capabilities. Let's look at what does a transaction in LakeFS look like. So LakeFS simulates transactionability using branching and merging capabilities. The first thing that we want to do, we'd like to create a new branch. Let's call it the transaction branch. Very original, right? This transaction branch is going to provide us with a consistent snapshot of our source branch. On our transaction branch, we can perform all the operations we want to be done atomically. We can upload new objects, delete objects, update tables, even create transactions inside that branch. When we finish with all the changes that we need to do, we can commit the changes into the transaction branch immediately merge it back into our source branch. Now notice that while we're making the changes, the source branch remains unaffected, right? And the changes will be introduced into the source branch atomically upon merge. In case of any error during the transaction, we can always drop the transaction, leaving our source branch clean. So looking at this, it might look like we have to make a little bit of extra steps, and this might look a bit annoying. But lucky for us, the high-level Python SDK already implements a transaction mechanism. So let's jump into a live demo and see that in action. Okay, so this is my Databricks workspace, and we have the notebook for the demo. And what we're going to do today is run some data transformations on our production branch as part of a LakeFS transaction. You guys seeing it right?
Can you
Great.
increase the font size?
Increase the font size. Better? Okay, but before we run the notebook, let's look at our LakeFS UI. So, as you can see, we have a repository called PyCon LT demo. In that repository, we have several branches, and we're going to work on the production branch today. Going into the production branch, the objects view is going to show me all the objects inside my branch. And we're going to work on the infamous yellow taxi data. And I've created a delta table from it. And I want you to notice that we have a single version of our table. Now, another thing I want you to notice is the commits tab. In the commits tab, we have all the commit history of our production branch. And these are commits that I made in preparation for this demo, right? So let's go back to our notebook. So the first thing I want to do is I want to read the data from my production branch. So this is the LakeFS Python SDK. And what I'm doing here is I'm initializing our repository and branch and using Spark to read the delta table from that branch. Okay, great. So we can see the table schema and sample data, and we can see that there are a lot of columns. Some of them are not interesting. Some of them have null values. So what we're going to do is we're going to use a transaction to do some cleanups. So I separated the code, the Spark code, from the LakeFS code so it will be more clear. I created a perform cleanup function here. And
Can you make it bigger?
I will. And what this code does is, well, the first thing, it doesn't want to count the rows we have before our cleanup. Then we're going to choose only the columns that interest us. We're going to drop the null values. And lastly, we're going to filter all the data earlier than 2020. In the end, we're going to count the rows again and print them to the screen. Now, this is our transaction. What we're doing here is from the production branch, I'm creating a transaction, and I'm providing it with a commit message and the commit metadata. These are the message and metadata that will appear in the transaction commit that we explained before. I decided to add, we can add any metadata you want. I thought it would be interesting to add the PySpark version for that transaction. And inside that transaction, what we're going to do is we're going to read the data frame again from the transaction branch. We're going to perform the cleanup and then write it back to our transaction branch. Now I'm going to start running it because it takes a couple of minutes, and then we'll continue talking. So basically what happens when we leave the context is that the uncommitted data immediately is being committed into our transaction branch and then merged back to our production. If I go to the LakeFS UI, you will see that under branches, I have a new branch created. And you can see it's called, just a sec, tx-something. That's our transaction branch, and that's an ephemeral branch, which means that it will be deleted once the merge is successful. We can also configure it to persist in case of errors, allowing us to investigate the issue live. And so if I go to the transaction branch under commits, you can see all the commits that the production branch had. Going to the uncommitted changes, you can see that we already started writing new data into our transaction branch. Great. So we're going back to our notebook, and you can see that before the cleanup we had over 98 million records, and after the cleanup only 41, a little bit over 41 million records left. And this is about to finish in any second now. And wonderful, it's done. So let's read the table from the production branch again and see the changes. So great, as you can see, only the columns that we selected exist. And here you have to have a little faith in me when I say that only data newer than 2021 exists. Going back to the LakeFS UI, we'll notice that in our production branch, going into our data set, we can see a new version has been created in our Delta table. Looking at the commits tab, we'll see two new commits over our previous commit. The first one is the transaction branch commit, which we discussed. And the second one is a merge commit from the transaction branch into our production branch. And if you're familiar with Git internals, what we do here is a three-way merge. So if I go into the transaction branch commit, I can see, of course, the commit message, which I added. And I can see the metadata that I added, which is the PySpark version and the value. In addition, I can see all the changes that were made on that commit. Great. Now, if we have a couple of more minutes, how many of you are using Databricks for your work? And how many of these people use Unity Catalog? Okay, so I'm going to show you something nice. We don't have a lot of time, so I can't really go into the specifics, but I didn't tell you something. I did something on my production branch, which I didn't explain before. I created actions on my branch. These actions are a post-merge and a post-commit hook. And what these hooks do is they take all the tables that I have on my branch and they export it to a Unity catalog. So going into the Catalog Explorer, you can see that I have a catalog called LakeFS PyCon LT Demo. If I press on it, I have the databases or schemas for each of my branches in my repository. Looking into the production schema, you can see the NYC Taxi Delta. And what you can see is the overview, the sample data, and the history of my data. That's pretty cool. So the last thing I want to leave you with is actually a call for action. If you like this demo and you like messing with data, I want to invite you to first join our LakeFS community, a thriving community of over 4,000 members, and to try out LakeFS. It's open source, it's free, you can also contribute to it. And if you want to everything bagel, samples repository, where everything is already set up for you, like an